after T plus 37 minutes. So about a minute left to go.
Yep, just a little while. I think we're tracking to 37 in around 49 seconds or so. So we should be just about a minute and a half. Where, again, as Amanda just said, we're going to relight one of those center engines. This will be the third time that we've tried this. We did it successfully back on Flight 10, and then we did it for the very first time back on Flight 6. This is not a deorbit burn. This is demonstrating essentially all of the systems you would need to do a deorbit burn. So that's obviously your Raptor engine, and then also your header tanks, your smaller tanks in the nose cone, where we have liquid oxygen, liquid methane in a smaller, more easily pressurized container, which we can use for on-orbit burns, and we're also going to tap into those when we do our landing burn. So this will be a critical capability. Once we go to full orbital missions, you'll have to do a deorbit burn to break out of orbit, send it back down to Earth. But in this instance, we're already on our way back down towards Earth. So this is just going to demonstrate the capability of turning one of these engines on. We should be coming up in just about 20 seconds or so, looking for one of those Raptor engines to turn back on. They've been off since we completed that successful ascent burn almost 30 minutes ago. Here we go.
Oh, Raptor ignition. And shutdown.
All right, there was that Raptor relight. Looks like engine 3 full duration. As Dan mentioned, that's a third attempt, and we just did it 3 times in a row. So congrats to the team, the ship team, Raptor team. And then there we heard nominal second orbital insertion. All right, so congrats everyone on the milestone. That was awesome to see. We're 3 for 3. We're gonna take another break, and we'll be back for re-entry at about T plus 45 minutes. We'll see you soon.
Ship is starting entry, good attitude.
All right, welcome back, everyone. The ship is currently re-entering Earth's atmosphere. As a reminder, we don't plan to recover the spacecraft today, but rapid and reliable reusability is the ultimate goal.
Yeah, the light show has already begun. You can see plasma starting to build on the windward side of the rocket there. And, re-entry is a critical phase of flight, and we need information on how the ship systems perform. Re-entry is also extremely demanding portion of flight because we need the ship to scrub off all of the energy we used to launch the rocket. So remember the 33 engines plus the 6 engines on ship that we used to get up into space, we now are using aerobraking essentially to scrub off all that energy. And of course, Starlink is a big part of this, giving us the views we have right now, and also letting us gather as much data as possible, which again is really the main reason why we do these flights. And the view we have right now is actually a really good example. As we mentioned at the beginning of the broadcast, we have some tiles on the leeward side of the flaps here, and we have some different mechanisms, some stud out, basically to see if these tiles will hang on. And we can see already here, it looks like we kept most of them, but I think I see a couple there that are no longer there, so the thermal team is definitely going to be digging into that and taking that data to help us iterate on V3. So yeah, Starlink provides us with one more path to collect data and help us rapidly iterate Starship's design.
And if the ship does manage to make it all the way to re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at hypersonic speeds, or more than 5 times the speed of sound. Re-entry is typically a portion of flight where we don't have communications with spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers. So re-entry so far is looking pretty good. You can see that plasma field. Also, again, with those missing tile experiments, especially, we're putting the ship through a lot today, but things are looking pretty good so far.
Yeah, we're looking good. I do want to remind people that we are pushing ship to the limits. We've done a lot of these missing tile tests. We did it back on Flight 10. Every time we do it, we throw something new and the ship makes it through. This time, we're really pushing it. We've removed these tiles in some of the spots that see the highest level of heating. And we remove tiles that have zero backup protection underneath. So there's essentially just bare steel. It's one of the heat of re-entry. And so do not be surprised if this is not a very smooth flight on the way down. But again, this is intentional. We are trying to find what are the limits for ship. How resilient are we to these different issues that could pop up? If we lose a tile anywhere in the vehicle, we want to know what that ultimate impact is going to be. So we've got a couple missing. We had a bunch pulled over the primary fuel, the LOX tanks, everything. This one, we've got a tile missing right on top. So that's going to see some of the highest temperatures during this re-entry, and there's just bare steel right underneath it. So we're going to see if Starship's robust enough to pull through that. Also have some tiles missing around the aft flaps, specifically on the leading edge. So again, we're getting a really good look right at the leading edge. That's getting really intense heating. So again, gonna see if it can make it through. See if all the flaps hold on. See if Starship holds together. But definitely could be a bumpy ride. But this is why we're flying. This is why we're flying in this part of the world. This is why we're putting Starship through these flight tests to really understand what its limits are. So we can then move on to the next thing. Just gonna be bringing ships back to the launch site for a catch. But for now, still on this suborbital. The light show continuing. Keep following it in. I think we got about 15 minutes until splashdown.
Yeah, Dan, it looks, you can see our speed our speed indicator in the bottom left there. It looks like we're starting to scrub off velocity a little bit quicker.
Ship is entering the peak heating phase of flight.
Looks like we can see some clouds down there as we pass through 70 kilometers altitude.
Yeah, the sun's starting to come up again. Ooh, there we go.
There we go.
Skirt is intact so far this time. If you watched Flight 10, you saw we entered with a little bit missing. That was ultimately traced to a little bit of buildup. We dumped prop on the way. We had a little bit of solid propellant buildup, and then either static discharge or the plasma ignited it, took out a tiny bit of that skirt, some of the aft flaps, but Starship, again, was able to fight through it, make it all the way to that landing burn. We addressed that, changed some of our prop dump con-ups, though, so should not be seeing that this time around. And as a reminder, in addition to these missing tile tests, we're doing kind of a unique flight on the way in. It's going to do what we call a banking maneuver. So while we're still going supersonic and even hypersonic, we're doing kind of a banking turn. And then we'll do a pretty aggressive turn right as we get into the subsonic and start doing our belly flop. And that's designed to essentially be the approach that we would do on a return to launch site and a tower catch. So don't be surprised if we see the ship start to turn and make a few maneuvers as it makes its way down to the Indian. And fun fact, even though we're doing all this turning, we're essentially targeting the exact same spot in the Indian Ocean we went to last time. All right, just about 12 minutes to go. Still looking good. That gives a pretty good view of those aft flaps where, again, on the leading edge, I think it might be on the one on the other side, we had some tiles removed with no backups behind it. So again, we're really trying to stress some of the most sensitive areas around Starship, where basically if you lose a tile, it's the worst possible spot. And if we're able to make it through this, then that tells us quite a bit about just how resilient this vehicle is.
Yeah, and that shot we just had earlier was looking at what we call the business end of Starship with all the Raptor engines. And those are the engines that we're going to be expecting to light for that flip and landing burn, hopefully in about 10 minutes once we get through reentry. Yeah, there we go.
Yeah, looking at E3, that's the one we did the relight on. So it's 2 for 2 so far. We'll see if it can go 3 for 3.
Yeah.
All right, we can see that speed just continue to bleed off under 20,000 kilometers an hour. Ship still holding together.
Yeah, and if you look in the bottom right, looks like we've made it all the way to the Indian Ocean. We're coming up kind of near Australia, the west side of Australia there, so pretty crazy. We're only 56 minutes in, and we've made it all the way, halfway around the world. It's actually a good demonstration of a future capability we hope to have on Starship where we will do point-to-point transport on Earth. So essentially travel anywhere in the world in about an hour or so, which is going to be pretty crazy. Imagine going from New York to Sydney in 1 hour instead of the 20 hours it takes currently.
And a reminder, so this camera is, we see some of the heat rate picking up a little bit. And this camera is embedded right in the end of one of those forward flaps, so you see it moving around. That's the flap adjusting to maintain control. Looks like we're getting into our bank maneuver. Now power sliding through the atmosphere.
External temperatures are coming down. Vehicle is now at maximum dynamic pressure.
All right, that was basically our reverse max Q, so most aerodynamic stress that it's going to see during reentry, we just passed through it. So we're past that, we're past peak heating. Ship's still holding together. So we're currently in this bank maneuver. We're gonna see it kind of roll over and do a pretty significant shift as we get down closer to the subsonic speeds.
Yeah, and that bank maneuver that Dan's mentioning is all in part of us to learn about the guidance, navigation, and control for return to launch site missions. So in the near future, we're hoping to return the ship back to the same pad we just took off on 59 minutes ago, and we've got to do some of these pretty dynamic bankings to make that trajectory work out.
All right, the light show kind of calming down as we're starting to move into the lower parts of the atmosphere. We should hit transonic, so hitting that transition between moving faster than the speed of sound and below the speed of sound in just about 3.5 minutes. Our landing burn should happen right around an hour and 6 minutes after launch, so we should be just about 6 minutes away from that. You can see lots of daylight. Everybody cross your fingers, see if our range team was able to get out there and provide any surprise views as Starship makes its way down. Oh, it's like they heard me. Ready and waiting, let's go.
Dan, you just spoke that view into existence there. And again, all brought to us by
RTS banking
Starlink.
maneuver has started.
All right, there we go. So we're now starting into our really heavy bank maneuver. Again, this does almost like a half circle loop to our actual trajectory. We're heading to the same exact splashdown point, but we're kind of doing a more roundabout way to get there, where it's this kind of big, long half moon loop and then a really aggressive and a twist right at the very end. And that would line us up with the launch tower. Starship, on a return to launch site, would fly over the tower, do a quick landing burn flip, and then come down for catching the arms.
How about that S38 decal there, staying strong on that view we just had?
Good to see the numbers back on.
Yeah.
All right, should be hitting transonic in about 2.5 minutes. Landing flip coming up in about 4. Pretty clouds there in the Indian Ocean today. Again, yeah, we changed our launch times. We launch in the evening now, so we get these daytime views down in the Indian Ocean. One of the things we're really looking for, the reason we have the drone, other than, yeah, that looks really cool, is we're able to kind of see the ship. We can only see so much from these cameras. You can't see like the vast majority of the heat shield. So we throw these buoys out there. We've got there's...
You spoke it again, Dan. There it is.
They're playing with me in the control room. All right. But we have these buoys out there. We have these drones that we're trying to see externally how the heat shield held up. Everybody saw from Flight 10, it had a little bit of a paint job, a little bit of a reddish hue. That was from those metallic tiles that we had tested, kind of oxidizing really rapidly in that plasma and then spreading those little oxide particles all over the heat shield. No metal tiles on this flight, so not expecting to see that.
Dynamic pressure is coming down.
Hope nobody gets seasick. All right, coming up on transonic shortly. It's about 2.5 minutes of landing burn.
Yeah, and once we get to around the 15-kilometer altitude mark, that's where we have a lot of flight history.
Starship is transonic, starting the belly flop phase of flight.
Yep, that belly flop phase that we perfected in the suborbital campaigns, we're entering that now.
Right, starting to get those Raptors ready. Should be 2 minutes away from landing burn. Again, we're going to do a flip. After we ignite those engines, we'll go from 3 down to 2 for the final phase of the landing burn and look for another soft splashdown, hopefully by our buoy and drone, which are hanging out, ready and waiting for a ship.
Seeing all 3 center engines have entered the chill phase.
All right, less than a minute to go.
The ship is making its turn for final approach.
And here's this kind of aggressive final turn that would essentially position it so it's right behind the launch and catch tower. Flaps holding strong. Landing burn in just under 20 seconds.
Ship landing startup.
There's our landing burn. Three down to 2.
Starship has landed.
As we said, we're not planning on recovering the ship today. Hey, welcome back to Earth, Starship. We are